Hey, thanks for coming this afternoon. I know afternoon sessions can be interesting. It's the end of the whole thing. Your probably brain is melted. Is your brain's kind of melted? They should be. You can't, if you've come to pass and your brain is not melted, you need to come talk to me of going to the right sessions. So your brain's thoroughly melted. So I want to just say one quick, that's why you're here. One quick pre-apology. I've had 10 sessions across 2 events this week. My voice is on the brink, so I'm gonna drink a lot of water in between if you don't mind. I think I'm gonna make it though. Promise you're gonna push through this thing. But if you see me feel a little raspy, it's just because I've just been talking a lot, which my wife says all the time. You actually do that all the time. I told her last night, she goes, maybe you shouldn't talk so much. I'm sorry, I got 10 sessions to do. So hey, I'm Bob Ward from Microsoft. Thanks for coming this afternoon. When I thought about building this talk, I thought of a couple things. One, there are talks at events like this that I have to do as part of my job. And I like doing them, trust me. I like talking about our new innovations, things we're doing, new technologies, AI, you name it. But I get to choose one that I really want to do. And one that maybe not cover like the latest stuff, but things maybe that have been out there, or things you're using now, but are more practical. So I thought, what am I going to do this year? Last year was like a debugging session, right? This year I thought, okay, what do I hear a lot about that people maybe are not getting all the facts straight about? And to me, what I've heard over the last even couple years is this topic here, availability groups. Couple things logistically. It is going to be so tempting for you to stop me and ask a question like, hey, I've got this AG with 3 nodes and a multi-subword network, and this isn't working right, and so forth. Please, let's not do those questions in this session, okay? BobWard@Microsoft.com. I commit to you, and if you know me well enough, if you've got a question at AG that's really in depth about a specific situation, send me an email. I promise you I will answer you. Maybe after the holidays, but I will address it. If you could, we'll take a couple of breaks during the session today to answer questions, but if you can keep it focused on what I'm presenting today for you. Again, it doesn't mean I'm trying to turn you down from asking a question. I'll take the hardest questions in the world. But if we get rat-holed in a very specific situation, we'll never get through all this stuff. Second, what about the deck? What about the demos? I've got some cool demos to show. Yes, I'm going to show some call stacks. Not a debugger, but at least some call stacks, right? Like, how did he do this stuff? Well, right there, Bob Ward MS, that site. We'll take a second, let you take a photo of it. The entire deck, I just uploaded in the speaker room. And the demos are in the deck. They're all recorded. And if you unmute them on a Sunday, you can take a nap and listen to me go on and on about always on availability groups, right? So everything's in there. And if you have questions when you see it later, like, how did you do that? You can ping me. I'll show you the steps of how I produce those together. A couple of quick things about this slide. The right is an ode to what happened in 2005, something called database mirroring. I remember being in CSS in those days when we launched that feature. And I remember distinctly, Steve Lindell, who's now retired from Microsoft, who was a big developer of that feature, came to me in CSS around 2008, and we just 2008, and said, Bob, we're going to rewrite this. And what is it called? He goes, it's going to be called Hadron. Hadron, high availability disaster recovery on. Hence became always on availability groups. So back in 2008, we thought about rewriting this feature, making it more robust, the mirroring, including the support for things like clustering support. That's kind of a legacy of where this all started. And in fact, some of the resources you'll see throughout the deck and at the end of the deck pay tribute to something like the Hadron Learning Series my colleague Bob Dorr wrote. There's so much content we built for so many years out there on the details of this stuff. It was kind of fun to go back and try to find some of the things to put this and stitch this together. So anyways, that's the context of what we're going to do today. Let's see if we can have some fun. So here's what we're going to do. A little bit about a why. Why do I think maybe people are using this? It's going to include a discussion on licensing. Bob Ward's going to talk about licensing. Yes, that's one thing I think you should know about that maybe some are confused on. Number 2, how does it work? That's the fun part, right? Data synchronization and failover. There were some fun demos I'm going to show you about how to trip it up, suspend data movement, look at worker threads, look at call stacks, some of those things. How does it work behind the scenes? And then finally, there's some extended availability group stuff I want to talk about. I want to make sure no matter what we do, at the end, I get to a demo to show you the public preview of the managed instance link feature for bidirectional disaster recovery. I built the demo. I want to show you how it works. Here's a tip. I promise you right now in this room, whoa, did I get it? Oh, I dropped my battery. I promise you in this room right now that there is somebody that probably knows availability groups more than I do. And I know people in the community do from this perspective. They deploy it all the time. They see it out in the wild. You pick a guy like Alan Hurt, who goes out there in the industry and does this for customers, follow their advice, look at their expertise, see how they practically do this. This is a talk more about what I think you should know about it to make sure we bust some myths about how does it work, maybe how it doesn't work, What could it be used for? How do you license it, etc. So here's what I hope to bust. It requires a cluster. Wrong. It's only supported in enterprise. Not true. It only works on Windows and requires a domain. Not true as well. It always requires a SQL license. Not true. You can't have high-performance apps. That's not true as well. Transactions are held up if a secondary goes offline. That's not true. You must manually synchronize instance objects. Not anymore. And they're not compatible with other features. Did you know when I put that on this first slide, when I first built this 3 weeks ago, I tried to, as hard as I could, find all the features that didn't work with AGs. It's kind of hard nowadays to do that, actually. So I don't even have a slide that actually says what doesn't work with AGs. Maybe you've run into something you should tell me about, but it was very difficult to actually go find that. And then finally, I always need to manage the AG in the cloud, and we'll talk a little bit about how we do things in the PaaS service kind of at the very end of the session today. So these are the myths that I think, that I hear people talk about, that I hope to bust in today's session. So why availability groups? This is what people tell me. I don't know about you, but this is a shared nothing architecture, different than a failover cluster instance, which means faster RTO and RPO. And most importantly, I get to use the other instance for something. Things like read workloads or backups or check DB. And it could offer me the ability to do an online move or a migration or an upgrade or even a rolling upgrade or patch. So out in the wild today, when people tell me, when I get into a big customer meeting, like, why should I use this? This is the kind of stuff we talk about, or even setting up disaster recovery along with this. Maybe those are familiar to you. You're like, yeah, sure, Bob, that's why I use it, that's why I chose it. But it's what I actually hear from even executives about why would this technology be used, and it's why in the cloud for PaaS services like database and managed instance, we use this actually behind the scenes to make some of our SLAs successful. Okay, what about licensing? Like, what is licensing doing a Bob Ward talk? It's because I see confusion around this, and it's not your fault. So first of all, did you know Developer Edition can be used for this? You can do developer and test scenarios with Dev Edition with an availability group. It is possible. I've done it. In fact, the demos I did on Azure were all with Developer Edition. So if you think that's not possible, you can to develop and test an AG scenario. Again, it can't be used for production. You can do evaluation as well, not for production. And certainly enterprise supports it, but maybe you didn't know that standard supports it. Now, it is a basic availability group, which means you get one, and it's got to be passive. So it's just got to be sitting there waiting for a DR or an availability scenario, but it is possible to actually do that. Now, this is the one that people usually don't know about. There's a concept now called passive secondary. If you've got software assurance or Azure Hybrid Benefit, you do not have to have a SQL license for a passive secondary. Any supported edition, and of course it wouldn't be for developer purposes, right? But one is free for availability, okay, like a failover, and one free for DR. And if you want to extend it to Azure, you get an additional free for DR. Now, what does that actually mean? What does passive mean? It means you really can't use it except for those purposes. Now, we're not monitoring this from you. This is a license thing for you to make sure you maintain. But as long as you'll set up AG replicas and not technically use them for any purpose besides checking them, backing them up, or monitoring them, you do not pay for the SQL licenses. And we started this in SQL 19, and we've extended that now into the cloud. And you can do DA and HR drills. If you look at the licensing guide, it says every 90 days, you're allowed to go out there and do a DR drill or an HA drill. So if you want to fail over and test it out, you're actually allowed to do that. This is a hidden gem that people don't realize is available to them today, on premises or in the cloud. Let me do this. Let me get through certain sections, and I'll pause for questions. Thank you. Okay, so that you need to, and I've got some visualizations. Like, look at this scenario. This is on premises. I've got a secondary for HA, a secondary for DR. Notice on the right side, I don't pay for those licenses, as long as I'm not using them. They're sitting there waiting for me to be used. Now, that violates the first thing I told you about why people use AGs, because I get to use them, but it's kind of nice that if I just want to use them for sitting there and waiting for availability for higher, faster RPO or DR, I don't have to pay for the licenses. And in the cloud, you get an extra one. So you're on premises, you got an HA one, a DR one, and now you want to put one in the cloud for DR as well. Notice you don't pay for the licenses as well. Now you're going to pay for compute and storage up there, but not the SQL license. So kind of a nice hidden gem. Let's go ahead and go with you had a question. You can ask a horrible question. So right here, if you see this, it says on premises. That applies to any cloud. Yeah. because it's not Azure. In fact, if you look at the license, it says not Azure. So yeah, good question. Okay, let's talk about, oh yeah, sorry, go ahead. 90 days. 90, you can do any of those. Yeah, there's no, here's one of these things, right? It's not like Microsoft monitoring you, right? But we are saying like, look, you need to adhere to the license guide. But yeah, it could be any one of these things you do in 90 days. Because we want to, I mean, that's silly for not allowing you to do like a drill to make sure this all works properly, right? Yeah, one more question. Yeah. Yeah, if you're doing a rolling upgrade, obviously when you do a rolling upgrade, you're going to start using it. So at that time when you do the upgrade, you're using it at that point. So that doesn't count as part of this HADR drill scenario. Now, if you go back, then you wouldn't pay for it anymore when it's passive again. But during that period you're doing the upgrade, yes, you'd be paying for the license. Does that help a little bit on licensing, though? I mean, like when I sat down and thought about doing a technical talk, I'm like, should I even put this in here? But I think people want to know, you know, this is all possible, right? Let's talk about how it works. I'm an architecture guy. I just love doing these kind of things. I'm already busting a myth right now. Cluster type equals none. You can only do a manual failover, and it works on Linux architectures. So you got an AG, you got a replica in a VM. You set up a secondary sink. You get one primary, up to 8 secondaries. 5 can be sync. We're going to talk about how that could be an issue for you if you go to multiple sync secondaries. I can do a planned failover. Notice here, not automatic failover. I can have a role as read-only. I can have a role as no connections. It's synchronous. I can also do an async, which is allow data loss, which means it's a forced operation. And by the way, when we say forced allow data loss, it doesn't mean you're going to lose data. If they're synced, then you wouldn't lose it, but we don't know that. So we need to know that if you set up as async, you must decide, hey, I'm going to make this forced failover. I'm going to take the risk that it's possible to have data loss. But we'll show in the demo how you can maybe check and see, am I synchronized? I've already busted a myth. You don't need a cluster to do an AG. You're like, Bob, why would I want to do that? Well, check this out. I could do that. I could say, oh, I've got an AG on Windows, and I want to go put my replicas on Linux and Windows. That's because the bottom core of the AG architecture, back from database mirroring, did not rely on clustering. Now, out of the gate, we did require a cluster. But in SQL 17, because Linux came along, we built this model. Why would I want to do such a thing? Does anybody know why you would want to build this architecture? Yeah, go ahead. You could avoid cluster type licenses, right? Well, Linux would avoid your Windows license. But what if I didn't need failover? What if you just wanted a synchronization system? Like I just wanted to have logs shipped more frequently, log blocks to these replicas and read from them or use them, and I'll decide if I can fail over or not. And as it turns out, you'll find out near the very end of this session, I can use this design for this manage link feature with a distributed availability group. Okay, so notice here, though, that the whole idea is, I set this up, it's cluster type equals none, but I'm responsible for the failover. When I do AG demos without showing failover, I just do this. It's not hard to set up. You can do it with certificates to get security between the nodes. Let's put clustering in the model now. I'm going to use Windows failover clustering. All of a sudden now it gets a little more interesting because now you have a sync which can do auto failover or planned failover. And you can have an async secondary as well. And you're going to use something called quorum, as you may know, with Windows failover clustering, to make decisions on when to failover and who to failover to. That's cluster type equals WSFC. And it's automatic or manual. And you're like, wait a minute, I thought it's only automatic. No, you could decide yourself to do a manual failover here. And if the sync is synchronized, you're not going to lose any data. That's up to you to make that decision to do that. Now, also notice here that it says you don't need a domain. Did you know that? Did you know back in SQL 16, Windows offered this idea of being able to do a cluster without a domain, with like work groups. There's some things you got to make sure that's synchronized, but sometimes I've built actual cluster systems with SQL Server without domain controllers. There's other reasons why you may not want to do that, but it's actually possible to do that. So this is the typical scenario of building a failover solution with availability groups. So I've already busted a myth. You don't need a cluster, but you can, and you would do it if you want failover type capabilities, and we're deeply integrated with the Windows failover cluster system. But you're a Linux person. Well, first of all, sorry, you want to put networks on this, right? You might do a multi-sub-network system and put a listener on it. You need to do a listener, right? Because you need an abstraction to go connect to this stuff. I don't want to have to go connect to each node. I connect to a single point called a listener, and I'm redirected to the proper secondary or primary when I'm needed. And if you're a Linux person, you can do cluster type equals external. So Linux systems offer failover systems, if you didn't know that or not. Several partners we work with do that. You could use open source with Pacemaker, with Red Hat Linux, DH2I, HP Service Guard. Several partners offer the ability to provide the failover logic. Now what happens in those scenarios, when we talk a little bit about failover, we've built resource DLL-like software to integrate with those partners on Linux. So if you're worried, like, how is the actual Linux stuff going to integrate with Microsoft SQL failover detection, we've got that figured out. So these are two typical architectures you might go build, right? One without a cluster, one with a cluster. Now let's dive deeper into the instances. Let's have a little more fun here. Notice this statement. You should think carefully how many of these you put on these instances. Why? Look at a primary. You've got a transaction. You've got a transaction log, no problem. You have multiple log writers. We do that for performance reasons. Those are the ones going to harden to the log. But look at over here, header worker pool and broker workers and a mirroring endpoint. And then you go over here and you have a secondary, which also has a worker pool and has redo workers and header workers and multiple log writers. And the log writers on each side are responsible for hardening the log for you. So you're like, okay, what's the big deal? Well, look at this. We have shared workers across these in these instances, but you have dedicated workers per database, per replica. Hence this craziness where people say, Bob, can I put 500 databases on an AG, on an instance? I'm like, sure. The docs say, we've tested 100. What if you have 500 of these workers out there now? And your max workers pool is set to a number where that gets to be like 30 left for your workload. What we do is we never go beyond max workers of your system minus 40 for this system. If you go to these crazy numbers and your max workers are a certain number, like say, I don't know, 500 or 600 based on the configuration of your server, you don't have a lot left to do your workload. And these will start not being able to do per database per replica. We'll have to trim it down so they're less efficient. And you're like, well, no problem. I'll just bump up max worker threads. Do you have the cores to support that? So when everybody gets in discussion with me about workers and databases, my first question out of the gate is, do you have the number of cores to support this? Where is your app running? And is the workers per core going to support the entire application scenario? So now it gets crazy. Like, Bob, you're showing a really nut stuff now. This is kind of like the flow that's going on between a primary and a secondary. And you're asking yourself, like, what are all those points there and what are all those boxes? The main message here is that it's a cooperation between user transactions, the log writer thread, and these worker pools and broker tasks. If you didn't know, behind the scenes under the covers, we're using Service Broker ourselves that we wrote under the covers to send messages and log blocks. Yes, we use the broker system we wrote way back in 2005 under the covers to transmit data between these systems, both log blocks and messaging about how to synchronize and coordinate. The cool thing about this story is you see all those white boxes. If you wanted to detail trace every aspect of the system, those are extended events. You could chain this together if you wanted to at a deep level to see exactly the flow, how things are going, and the duration of each piece behind the scenes. Which tells you out of the gate, if you wanted to, you could really get deep in debugging of this if you started running into synchronization problems or performance problems. But let's have some fun. Let's go do some debugging. So first of all, I'm just showing you here the layout of what I've done with my AG. Yes, I get to pick the names of these things based on the World Series champions. Yes. No boos in the audience from Astros or Diamondback fans. Sorry. So here I've got a primary replica, and I've got a secondary that's synced, and I'm going to have a secondary that's async, because I want to show you kind of some of the properties of how this works. I've also built a listener, and in this particular case, I only have one availability database that actually is going to go with this. And if you look over here, I'm just using some of the common catalog views to give you a sense, how did I build this thing? Some are synchronous commit, and you see the bottom one is asynchronous commit because that's the async replica. Notice the failover mode is showing you that for the first two, the primary and secondary, I can do automatic failover. I'm eligible to do that. But for the third one, there's only way to do it is a manual failover. We're going to talk about session timeout later during synchronization, but you can see that property, and that's going to be the amount of time that we detect have we lost connection with the secondary. Okay, that's lovely, but then how does this thing work a little more internally? So here I've just got a simple query I'm going to run an insert against my table, and I want to see the impact of the different workers. So if I scroll down here, here's a typical query I use to kind of synchronize or eliminate and filter what are the workers involved with availability groups. First of all, you see these broker tasks. These are all background tasks. Notice in some cases, the scheduler ID is this huge number. Those are called hidden schedulers to help make worker thread processing more efficient. But scroll down further here. Notice I've got some of these things called, well, first of all, here's log writer. That's the one hardening the log. You'll find that interesting because that's a very big task on the secondary. And if that gets slowed down, it's going to slow down performance for everything. So notice these DMVs. If you ever go look at these DMVs, the number of threads here are only the dynamic threads, not the dedicated ones. So what you're going to find if you pulled these is you're going to see these fluctuate. Like if you run this insert and you go back and don't have any activity for a few minutes, you'll see no threads in the system. So if you're ever looking at these threads and thinking that's that total number minus 40, it's not. It's only the dynamic ones we spawn up to do activity to capture log traffic. Okay, so let's go over here now and look at the secondary. Notice the secondary, there's no capture threads listed, but there are redo threads. Why are there redo threads listed? Because of the fact that on the secondary, what are we doing? We're capturing hardened log blocks, but we're also doing redo activity to roll forward continuously as much as possible transactions on the system. And you can look down and see these parallel redo tasks. That's something we do for efficiency to make things faster on the secondary. But notice here are some of these hater work threads. Now, why am I showing you this stuff? Because I want you to see what it looks like on a normal system. If you're an AG system, you've not seen this before, you're like, what is all this stuff? This is the background of how we're processing things. I'm going to show you in a second what it looks like to have like 300 of these databases. So let me get a little bit more look about the sequence that we talked about. I took the X events in that diagram and I created a session for it. I just created and listed them all out. And if you go look at these things, you can look at some of these session IDs and you can see the sequence of how things are processing. Now, would you ever do this normally? No. But if you start having problems, you would go maybe use some of these sessions to actually go through the system and see what is the duration of each sequence going on. Because it's a cooperation of your transaction that's starting the transaction itself and some of these worker threads. Notice that log writer is the one, if it goes back to this X event data, that's the one doing the flush because that's the separate log writer that's doing commits for your transactions. And it's responsible for making sure that you have like a write log wait that may show up, right? And if you look down a little further, notice these capture log block workers. You look at here and you can scroll down and see, well, what does one of those look like? Well, it's one of these capture log wait types. So if you see these wait types show up, that's not bad. That's just a normal system capturing changes in your primary, getting ready to submit things to the secondary. Now let's do some debugging. Let's go look at a call stack, what this looks like. I'm just using the SQL call stack resolver tool you can download yourself, and I'm pulling in to see what a call stack looks like. This is a typical call stack for a hater worker. This is what it looks like. Behind the scenes, these workers are just on a queue waiting for work to do. And the biggest thing that they do is they look for changes. They're looking for log changes to be captured, and they're going to go process these things and put them and send them across to the secondary. Now, these capture log block events have modes. Part of it is to capture, part of it is to send. And if you look at one of the other modes for sending, it's a broker task. So now you see the cooperation between a thread that's capturing the change and putting it on for a broker task to do the messaging. It's an abstraction of our code. We want one piece of code to sit there and just process messages inside the actual always-on availability group system. We want one set of threads that know how to do broker transmission between the systems. Back to our diagram. So if I look at the call stack here, I can see I've actually got a broker call stack. You're not going to normally go through these call stacks, but it's kind of fun to go look behind the scenes and say, what are these things doing? How are they cooperating and working between? And again, if you had just tons of databases, you can see maybe the problem here that some of these things may not be doing anything, but they're still taking up worker threads on your system. This is what a secondary looks like. So based on doing that transaction, it's going to look a little different on the X event side. There's going to be less events to actually look at. So going through here, you can see, I'm going to run this transaction, and I'm going to go through and actually look and see what it looks like. So notice there are less events. Like, Bob, why are there less events here, right? Because on the secondary, I'm just receiving things and hardening them and redoing them. There's not as much activity that's required on a secondary. So if you're wondering like, okay, so does the number of databases matter for secondaries? It's less of an impact, but it's still a potential impact. Why is that? Because for synchronized replicas, the rate at which we can harden the log on the secondary dictates performance of the primary. And we're going to see that during data synchronization here in a different demonstration. So I'm just showing you the different tasks. Like here's the log writer task in your secondary. That's responsible for hardening the log down in that secondary replica. So it's possible for you to go debug these things and kind of see what's going on from their processing. This is what it looks like to have 300 databases on a primary. I said, jack it up. Let's just go put 300 databases on there. Now I want you to scroll in and see what these threads look like. So if you go look at even just the dynamic threads that are spawned up by doing inserts, check that out. It's like 400 threads there. And by the way, on this system, I only have max worker threads at 0, which for the number of cores I have is like 576. Can you see the problem? What if you put a massive workload in the system? What would be your behavior? You get like thread pool waits. You start getting timeouts from your application and queries because we can't get rid of these things. We have dedicated and shared, but we're not going to trim this down too far because we can't process availability groups if we do that. We're not going to sacrifice processing availability groups for your system, for your app, just because you got a big workload coming in, because you made the decision to put that many databases in a replica. This is why you got to be careful to go to something at that level. Okay, so you got to feel for if you got into a system, what the different threads look like? What are the different X events I could do to trace the system? And what can I see differently in the system? So I'm looking over here now and showing you, look at all the different threads, the worker threads with that capture weight on there. This is what it looks like to have that many databases on a system. Okay, any questions a little bit about that? Like how does that work? Number of threads, have you run into this scenario before? Yeah, way in the back. Can you speak up a little bit? I can barely hear you. How many what? Yeah, it's per replica per database. So yes, the number of AG, so think about in terms of I've got an AG and I've got, which is a replica, and I've got, which is like primary, and I've got a database. If I had 5 AGs, one with each database, it would be no different than having 1 AG with 5 databases, if that's kind of what you're asking. So it's really the database unit that matters is per replica. But know this, there's some dedicated that we can never get rid of. And there's some dynamically that spawn back and forth. Yeah.
But it sounds like larger.
We'll talk about that near the end.
No.
Yeah, we'll talk about that near the end of the session, about Azure a little bit. Okay, let's talk about data synchronization. So the first time anybody asked me about a problem with data synchronization, the first time they asked me about that, I asked this question. Do you need to synchronize? And they're like, what do you mean? Of course I do. Doesn't everybody do that? And I'm like, no, I'm really being serious. Like, do you need a synchronous system for automatic failover purposes? And literally they go like, I hadn't really thought about that before. Like, maybe I really don't. Like, maybe I'm really just doing this to asynchronously get my changes on a secondary so I can just look at those changes. So anytime you start talking about data synchronization performance, always think in your mind, do I need to actually do this? If you need auto failover, then absolutely you got to go do this. I'm sorry? Well, of course it depends, but I'm saying that's why I always ask the question. Like when somebody says I have sync performance problems, they're like, well, do you need to do that? Now, again, the answer could be I need auto failover. Well, you got to do it, right? What I'm going to show you in a second here is something you may not know. And that is we're not going to penalize primary transactions for the sakeness of being synchronized. You're like, what do you mean by that? We'll show you. Okay. So this diagram here is kind of a more higher level view of that crazy thing I just showed you with the sequences of how we do things. Flush the log in the primary, capture the changes, send it to the secondary, flush it on the secondary, and redo it on the secondary. If you have a sync replica, we wait for number 5. See number 5 there? On the primary, we wait for that. And we wait until a session timeout. But then if it times out, we keep going. Huh? We'll show you in a second what I mean. If it's async, we don't wait for number 5. That's as simple as it gets. So the performance of flushing logs on a secondary is critical to primary performance. Obviously, flushing logs on the primary is, but what I've seen customers do is set up a sync secondary, and the performance of the sync secondary isn't even close to being from an I/O perspective and a compute perspective to the primary. And when you underpower your sync secondary, you are obviously causing problems on your primary just by doing that alone, because we need both of these operations to harden to do a synchronous operation. But again, if we time out, we're not going to wait. What do I mean by that? So you may have seen these wait types before: write log and header sync commit. When we have a sync secondary and we pull blocks to the secondary and things are synchronized, you will see both wait types for a single session. Huh? That's because when we send a transaction to a secondary, we asynchronously or harden the primary. We do it parallel. But the primary transaction doesn't complete until both of them have finished. This is why you can see both wait types. That's not a bad scenario. That's normal. What if the secondary, though, is not reachable? There's something called a session timeout, 10 seconds. If it takes longer than 10 seconds, guess what happens? We go to what's called the not synchronizing state. Maybe you've seen that before. But guess what happens to the primary? We just keep going. So what happens now, though? I can't auto failover, but the primary can keep going. So again, we're not going to sacrifice failover needs for keeping your primary going. This almost looks like an async secondary now, right? We'll kind of flip modes here if a timeout occurs and says, hey, we're going to keep going to the primary while the secondary maybe comes back up. Let's say it tries to come back up. What it's going to look like now is this, synchronizing. So secondary is trying to catch up. The write logs are still happening when this occurs. But if we think it's too far ahead, we do that. So if your secondaries get way behind, we might throttle you on the primary to make sure it can catch up enough. So again, we don't sacrifice failover, but after a certain point, we are, to make sure the secondary can get synchronized at some point. And when the secondary gets synchronized, you go back to that mode. So here's a myth. That isn't bad. That wait type is not bad. I heard people say header sync commit, bad wait type. It is a bad wait type if it takes forever to do it on the secondary. But the existence alone is normal for an availability group. So let's put a twist on this scenario. What if I've got two of them? Notice here that the header sync commit is a sum of both waits. That may be something you didn't know. So the more secondaries I add, the longer the commit time for header sync commit becomes, because I must wait for each secondary to harden before the primary can continue. Notice the blue box. You asked about the cloud. One thing we do different. In Azure PaaS, we don't use Windows failover clustering. We have our own system with the service fabric. And we figured out a way to make sure only one has to synchronize to make this happen. As one synchronized, we can fail over. That's all we care about. So in the box, though, with SQL Server, we both must commit. Now, what if one of them gets cut? Notice it goes back to only one. We only have to wait for one of these things, and we can fail over if they're synchronized. So if you've got multiple sync secondaries, I understand why you're going to do this. It's a protection mechanism for these kind of type scenarios. But realize what's happening. I've had customers put up multiple sync secondaries, and they powered one of them and underpowered the second one. And all of a sudden, they got slow. Because the second one is slower and holding up the entire process. Yeah. It's a good chance for me to take a drink. It's a plus. So that's the sum of these two. It's not a serialized, it's just the addition of both. So it's not like we wait one for the other. I'm just saying the wait time is the combination of the wait for one and the wait for the other. So let's say that it took 1 millisecond to wait. If it takes 1 millisecond to wait for the first one, and it takes 1 millisecond to wait for the second one, it's 2 milliseconds total to wait. We're doing it in parallel, don't get me wrong. It could be they're so fast that it's not that big of a deal, but make sure you keep in mind that it's the summation of waiting for both that make you wait on the primary. Does that make sense? No? It could be max. If you want to call it max, that's fine. You're right, it is max of the two. You're right, it's max of the two. I'll fix the slide. So it's not an accumulation of like 1 and 1 means 2. If it's 1 comes back at the same, it's the same. But I promise you, with 2 of them, what I've seen is the second be underpowered, and it actually ends up being like the sum. Yeah. It's the session timeout that I talked about. Yeah. No, you would have to go do that yourself manually. We will use that synchronization throttle. So the question is like, if this thing is so far behind, do we like just forget about it? No, we don't. You have to yourself take that offline. We're going to try to let that thing synchronize and catch up. So in those scenarios where it's way behind, maybe you want to take it offline first, reseed it, whatever you want to do, right? So yeah, that's fair. I should change it. It's a max. You're absolutely correct on that. But notice you can still fail over if it's synchronized. So if the first one's synchronized, you can do that. Yeah. I'm sorry? Well, if you look over here, if you look back here, excuse me, this is a 10-second timeout, which means we will not go to this mode. Whoops. This is the impact. When this occurs, we're going to wait for 10 seconds to recognize that. You know what I'm saying? So it'll hold up things, which is why you can change the session timeout if you want to. That's a configurable option. But yeah, we're going to wait for 10 seconds to decide, can we keep going and see that it's not around. But also keep in mind this, for a secondary that's behind, but it's not cut, it could look like this. And it's fine for a while until we get to this throttle mode, right? Where we decide, oh, and I don't have the numbers from when we make that decision, but if it's behind, it's synchronizing, then if we're behind, we're going to go to that throttle mode. And notice when it's in that state, you can't fail over. It's got to be in the green state. It's always got to look like that to decide to fail over. Yeah. Oh, there was another question. Yeah. Yeah, I do. I'm going to show it in a second. Okay. One thing I want to add, though, that's new that we added in SQL 17 is that. So let's say you did not want us to actually keep going. You need to make sure, in this case, that both secondaries have but the word commit's terrible here. We want to make sure both secondaries have hardened the log before I allow things to keep going. And if one of them is cut, take the AG actually offline. So that's an option we added. The default's 0, which is another behavior I've been describing. But if you want to go through and say, hey, I got to make sure at least one secondary is always hardened, we will wait for that. And if it goes offline, we'll take the AG offline. So there is a way to kind of change the behavior I talked about not waiting around. And that's the setting to actually go do that. Okay, let's go look at the demo. So there's a nifty way to do this without cutting the cord or network or something. I'm going to go add some transactions. And I'm going to go here. I'm going to look at, and I've got write log waits going on. And I want to go see, what does a header commit look like? So you see write log, write log, write log. Then all of a sudden now you're going to see a header sync commit show up. This is how both wait types can appear for the same request in these DMVs. If you use Xevent, you can see the actual sequence of these. Now things look great, but notice here that things look synchronized. It's fine. And if I go and I can go look at DMVs to say, hey, let me go see what the LSNs look like. So if you wanted to know, can I manually fail over and be synchronized, even for an async replica, you can look at these particular DMVs and see, are they synchronized? Are they hardened the same? So again, it may not appear that they are, but these values could help you make some of those decisions to do that. So let's go have fun here. And one easy way that I love what we put actually into the system is we can actually go suspend data movement. So what we're going to do is we're going to tell the system, don't send changes to the secondary anymore. Almost like I'm cutting the cord, like I've just did the session timeout. And all of a sudden you see in the dashboard things look bad in the case that it's not synchronizing. And what does that mean? I can't fail over. So what does it look like down at like the DMV level? So let's look at the waiting requests. You can go over here and go run a transaction and see now that the waits will show up as only write log. I have no header sync commit waits because I'm not waiting on the secondary. But I want to go see actually what the ramifications are for the system in terms of the AG health. So I can go over here, excuse me, I can go over here and look at, do I see, like one thing I look at the dashboard is this estimated data loss. So we're trying to calculate, based on these changes we're seeing, how much data would you potentially lose in terms of time to the actual secondary? And the DMVs give you more information about the LSN. So I can see here, here's a not healthy state. Here's the not synchronizing state from my diagram. And if I look over to the right, I can see information about the LSNs being way off. The bottom row is the primary. See how far the number is ahead of the secondaries? So I know now that if I try to do a failover manually, I absolutely would lose data. There's no way to actually get it back. And in fact, I think what I have in the demo here, so I try to go in and do like a manual failover. Now, one other thing I want to point out, notice down here, if you tried to go truncate the log, you can't. It's full recovery. we can't get rid of those log records to truncate it because we haven't shipped them to the secondary. So in this case, when we're not synchronizing, you have a log truncation problem still going on. So when you talked about getting way behind, you may need to cut the cord there because all of a sudden you can't truncate your log in the primary. So even though we're not waiting for the secondary, we don't want to truncate those transactions because how do we ever get the secondary synchronized if we don't do that? Okay, so let's go here, and I think we're going to go resume the data movement and see. You want to see about this partial healthy state and this synchronizing throttle. This is what it looks like. So here we go, partially healthy because the secondary is trying to catch up to the primary. Now, again, we're going to do write log waits. We're not going to do header sync commit waits because we're starting to get the secondary caught up. But you're going to see I'm going to pump so many transactions in this system that I get that synchronizing throttle wait showing up. So the nut of this is we're not going to wait for that secondary, but the secondary gets way behind. You are going to potentially have primary waits going on because we're going to eventually throttle you and say, we got to let this guy catch up because you intended for that to be synchronized. And eventually you can look at these LSNs and you can find out the fact that, yeah, it looks like it's kind of catching up. In this particular case, it catches up pretty quick. I can even truncate the transaction log. I go back to my dashboard. Things look healthy. So you kind of see a little bit of a demo. You yourself could go test this out, obviously not in production, by resuming and doing suspend. Or you could try to just go cut the connection to the secondary. Yeah? Yeah, that's a question he asked earlier. Like, there's a point where we get too far behind. We don't do that, though. Like, if we get too far behind, we'll never say, just forget about it. That's up to you. You would have to go, like, say, take this secondary out of the AG. So you yourself could see how far, but if you see your primary getting that impacted by this, you probably would want to take that secondary offline, right? Let the primary continue, then bring it back on later. But remember, when you bring it back online, if it's just using log changes, that's a long time to get synchronized. You may need to reseed it in that particular case. Sorry, other questions? If you start and add the secondary back or turn it back on, it will start replaying the logs. That's why we can't truncate the log. No, you cannot do it offline. You have to reseed at that point. You reseed the database. Yeah. You can take it. You can put it back to the G, but you need to reseed it at that point. Otherwise, you're just going to start catching up again. You can't replay the log. You can't go say, let's go restore the logs or something of that nature. You need to reseed the database at that point. Okay, so that's synchronization. Let's talk about performance. One of the things I love about AGs, remember that diagram again, is that for all those sequences, you have perfmon counters for every single piece. So if you're kind of trying to measure performance between all these pieces together, you can actually do that. And even further, you're going to go crazy on this. There are X events for everything I showed you in that diagram. You could combine X events with perfmon to get a very detailed, granular look at every part of this system, especially when we start having issues. So a couple things. Number one, redo performance. I've heard this stated before. It's not true. Redo performance does not affect sync performance, but time to recover after failover. Does that make sense? Because remember, all we're waiting is for number 5 right there, not for the redo part. So if redo gets behind, you're not going to affect sync performance, but the time it takes to fail over on the secondary and get the database up is affected. And large parallel index builds will slow you down. And there's really no great solution around it, unfortunately, except number 1, don't do parallel index builds if you can. And 2, do them in chunks or do them offline or do reorgs. That's because these are massive log transactions that have to be shipped to the secondary. And that's going to bottleneck everything else you're sending for your transactions. This is something that has plagued us since the dawn of time, and I don't know how to solve it yet. And even in the cloud, this is an issue. So yeah, this is an issue. Now, if I don't get to this, I want to make sure I state, definitely in the secondary, enable something called accelerated database recovery, which we started in 2019 and have in 2022. Why? That speeds up undo performance on the secondary. Because when we do recovery, we have to do both redo and undo. And if you have active transactions, when you do a failover, which is possible, you want that undo to be fast. Okay, here is an interesting demo. Does a secondary affect replica performance, like a workload? So I'm using some perfmon counters here. Batch sent to replica, transactions per second on the primary, and some ones you haven't seen before. What is the delay of transactions? And how many transactions are we mirroring to the secondary? What does that rate look like? And I'm going to go over here, and I'm going to run that workload. Of course, we're the champions. I just loved running these demos over and over, that we're the champions. So notice these are massively large rows, 5,000 characters per row. And you don't know if this looks good or not. You just know, like, this looks like the rate on my system. It's not a sign in this demo to say, oh, that's a great set of numbers. What I want to show you is that on a secondary, if I run a massive CPU workload, what happens to the primary? So notice here, header sync commit weights are kind of look like a certain number. That doesn't look bad probably in our system. It could be okay. But what does it look like if we do something on the secondary? So let's go over the secondary here. Now let's add a couple things on the secondary. Let's see how fast we're getting bytes from the primary, and how fast are we flushing the log on the secondary. Remember I told you about number 5? So I want to go run a crazy workload. I'm going to go run a bunch of threads doing read replica queries at 100% in parallel. I want to see what happens. So let's go back over our primary and see what it looks like, and watch this graph tank. Wow. And you're like, what? All I'm doing is run a read workload over there. Why are my flushes being affected? Why is everything being affected? It's like the log should be flushed in the primary just as well as the secondary. Like, I don't understand what's going on. So let's go back over the secondary and see what it looks like. So I go to the secondary and I'm like, okay, what does the log flush look like on this? Well, first of all, here's the header sync commit weights. Way high now, because I'm waiting for the secondary to send me stuff before I say everything's able to go forward. Now here's, oh my gosh, look at this. So what's happening is there's so much CPU pressure on your secondary from these read workloads. Even though the log writer's on hidden scheduler, it can't have enough CPU cycles to run. This is not an I/O problem. This is actually a workload problem on your secondary. And the moral of this message is, be careful what you run on your secondary. Because I've had customers go, they love the fact that you read workloads there, but then they go take some system that's underpowered, or they run huge CPU workloads that affect the ability for us to process log hardens on a secondary, which affects the ability to do your transactions on the primary. The whole system comes to a grind. You see that? See, I can't send as many because I'm not receiving as many. I can't receive as many because I'm sending as many. The whole thing is just a chain reaction, and it's all due to what you did on a secondary replica. You guys see how that could be an issue? You're going to need to go check that kind of type of situation. So when you see a primary performance, you need to do the right method here. If I go back to my slide deck here, you need to spend time doing this. Let me go see what it looks like from an overall picture. But don't be afraid, and don't, what I'm saying is make sure you go look at like a secondary system, and don't just look at the I/O of the secondary system, which is a big effect here. But it could be something like a read workload that affects deeply your situation. Okay, so in 2016, I remember being in the engineering team. Lindsay Allen, who now works in an AI space, was in our product team. And I was in building 16 one day. This is where we used to be on campus at building 16. And I walked over and she says, Bob, did you know what we did in 2016 to speed up availability groups? And I'm like, no, I don't know what we did. She goes, we turbocharged it. And I'm like, Bob Ward, blog post. So I thought to myself, I'm going to go throughout the building and talk to the developers about what did they do to turbocharge 2016? Because prior to 2016, we were having customers that were actually having issues with running primary workloads during availability groups and it affecting the overall process. So what happened is the team went through a series of improvements to reduce the number of worker thread connections, the number of pieces together to make this work in that diagram, multiple log writers, parallel redo, and you can see the chart to the right. So provided I had a secondary that was powered just as much of a primary, the yellow bar down there represents 2014. And in 16, look at the bar at the top. So I built this blog post, you can go read it today, called Always on Turbocharge. And the whole idea was to prove to you that with the right amount of horsepower on your secondary, and the right amount of making sure you don't affect the secondary with a massive thing like I just did, it is possible to achieve pretty decent performance on an always-on primary replica availability group. Notice the top here, that with a OTP type workload, we achieve 95% of a standalone instance with a sync replica. So if you're out there saying like, I can't put AGs on my system with a primary, because it's just going to tank down my primary workload, it is possible to actually go do that. But the message that I tried to put in the blog was not all just fun charts and stuff, is do not underpower your secondary for a sync replica. For asyncs, it doesn't matter. Put it on a very inexpensive system because that's up to you and how much data you want to be synchronized there. But for sync replicas, it's critical it be a very high-powered system, which is why in the cloud, you were talking about the cloud, for a business critical service tier, they're exactly the same. Those nodes that run a business critical service tier for those replicas are the exact same powered VMs and nodes. Okay, let's talk about failover. Let's have some fun here. Here's a couple of myths. Failover only occurs of a hardware OS problem, and failover detection is only at the instance level. Now, it normally is at the instance level, but it doesn't have to be. So here's Bob's auto failover revealed slide. In the clustering system, we have the Windows clustering resource, something called a resource monitor. We wrote a DLL called the resource DLL. Now, we've had that around for a while in failover cluster technology, but we enhanced it for availability groups, and here's how we did it. So look over to the right is your SQL Server. So first of all, what we added was the ability to call a stored procedure called SQL Server Diagnostics. That stored procedure is built into the engine to go look at the health of SQL Server. And along with it is something called a health check timeout. It's like 30 seconds. So there are two things about this stored procedure. If you can't run the procedure, the health check timeout expires, we're going to do a failover. And we call that is alive to the cluster manager. Or that procedure could return an error based on something called a flexible failover policy, which you control. So in other words, now we can go look at the health of SQL Server, not just the overall system, and say, hey, maybe we should do a failover based on this. Notice the health check timeout is actually configurable. Second of all, we wanted to support something called a lease timeout, which you may have heard before, with something called looks alive in the cluster manager. Why do we need that? Well, it could be that SQL's kind of running okay, maybe, but there's actually a priority preemptive thread running in the engine that is going to tell us, hey, and it's 20 seconds, that I'm going to talk to what's called a shared memory on the system itself, and I'm not going to rely on a query. So notice there's like two levels of protection here for failover. One is based on a query sent to the engine, and a fairly sophisticated one than years before. The second one's based on more of a coordination between threads that's not a query. And notice that lease thread in SQL, it runs in preemptive mode, so it's not affected by other types of workers, and it runs at a high priority within the system itself. So for high CPU problems, the system still could actually behave correctly. Because what happens is the resource DLL and the lease thread are talking to each other all the time. They're doing something called the lease negotiation to make sure things are healthy. And if that timeout exceeds where they're not, that's going to end up doing what? It's called a failover. So the resource DLL coordinates with SQL Server and the cluster manager to make failover decisions. Now notice when a failover occurs, what we do. When a failover is going to happen, we take the primary offline to avoid something called a split brain problem. If we did not do that, you could actually have two replicas that think they're both primaries. That's called that famous split brain issue. So that's kind of the mechanics behind we do failover, and I've just kind of proven to you that the fact that it's not just an OS issue or a server issue, and the fact there's another option called a database health detection. That's optional. We added that in 2016. So if a database becomes corrupt or goes offline in your AG, we can also issue a failover independent of this. Now remember this though, AGs are made up of what? What's inside a replica? What's in a containment in a replica? A database, right? But you can have more than one. So if one of the databases goes bad in that AG, we will do a failover. And notice here that most of these checks are to instance level, so no matter what the health of all those databases are, if that option is not set, we're doing a failover. Notice these are the ways you can configure things. Configure the policy to decide this is something called a level. You can change these timeout values. Now here's some scenarios, but before I say that, here's something very important, and this is a beautiful thing we added for failover diagnostics. You've seen Xevent before in the system. So we know how to write an Xevent file in the SQL Server team. We know the format of it. So in the resource DLL, since we're calling this SQL Server Diagnostics, we write a separate Xevent file outside the engine called the SQL Dia Xevent file. We'll show what it looks like in a second. So you can do independent analysis of a failover, even if the engine is down, of what happened from this resource DLL perspective. Here's some scenarios that you might run into and the different things that kick in because of it. Notice here that some are lease timeout scenarios, some are health check timeout scenarios, and one's even a health check failure. Here's a couple of tips. I would use the default policy, even though there are more granular policies. Do you know why? I tried for 1 week to break SQL Server to cause those detailed levels to kick in, and I couldn't do it. Like, I would kick in level 3 every time I tried to do something. In fact, the demo I'm going to show you, I kicked in level 3. So I don't see a need for you to use those more advanced options. You can take a look at 4 and 5. They're very detailed options. Maybe it's something you want to look at, but I'm not sure it's something you need to actually do. The secondary replica for a failover is chosen on the order it's added. So if you go in and say, hey, I'm going to add 3 replicas, which one does it choose to fail over first if, say, all 3 are available? It's the order they're added, not some other typical order. And then finally, make sure this is very important. When you do a failover, an auto failover occurs, we still have to do redo and undo. So if you're expecting, oh, I'm going to fail over, this thing is going to be up in 2 seconds. If redo's behind, that's not true. If it's a lot of undo to do, that's not true, which is why using ADR could be critical for your environment to make sure that the undo processing when you do failover is super fast. And by the way, in the cloud, in PaaS services, we turn ADR on and we don't let you turn it off. We don't let you configure it because we have an SLA to maintain in the actual cloud. Okay, let's go have some fun with failovers. So this is what a manual failover looks like, and I'm using the always-on health session to do it. So that's one piece of a diagnostic thing for you right now. You have something called the always-on health X event session in the engine, and you can go see what are the sequence of events that have occurred that maybe a failover happened. In this case, I'm just doing a manual one. I'm doing an alter server statement. I'm going to go through the process of seeing role changes. Like, hey, I'm doing manual failover, so now a failover is going to go between a primary or secondary. And if you're wondering, like, well, what does it look like inside the engine to do that? You can see this coordination happening here between the resource DLL and the engine. So looking at this call stack, and this is the actual alter server command, we actually see this thing called header proxy signal, header controller. We, behind the scenes, are actually sending a signal to the resource DLL saying, hey, I think you should go initiate a failover here. So SQL Server in the engine doesn't do it, and it shouldn't do that, right? It needs to be coordinated with the cluster manager. So because we have this coordination with them, this signaling ability, we can say, hey, you guys go signal this resource failover event. So I just do a manual failover, that's what it looks like. So I thought to myself, how about to trigger an actual real failover? Take away a disk or something kind of interesting. No, let's have more fun. Let's be stupid. Let's go set max server memory to 512 on the system, 512 meg, and see SQL cripple. So all I did is just set it to 512. Instantaneously when I do this, watch this happen. Now I'm going to use the listener below so I can stay connected here. I'm going to run this command and use the reconfigure. And within like seconds, this gets really fun. So I'm here looking at the dashboard. I'm like, okay, this looks fine. It's no big deal, right? Everything looks healthy. And then very quickly, things fall apart very badly. And that's because I've squeezed down SQL Server memory so bad that even the worker threads can't allocate memory for header. So things look terrible here. And I'm trying to go figure out like, okay, this has happened now. Let's say I didn't know I set memory like that. Okay, so I set this kind of weird thing, but this failover occurs. I don't know why. Let's see if we can go figure it out. So I'm going to go in here. I'm going to go look. Let's go look at some diagnostics. So I still can connect to my listener, right? I'm using my listener because a failover actually happened at this point to VM2. So if I use the listener, I can always go take a look at the information. So I'm going to go down here and I'm going to see you can see it's on the secondary side here. I can look and see that my primary now has become my SQL VM2, which used to be the secondary. But I can also go here and look at particular type of health information. Because what I'd like to do is kind of do a little bit more of a diagnostic, like this wasn't a manual failover. This was actually an auto failover, like what happened? So let me go do that. So I'll go over here and I'm going to go look at the always on. But first of all, just to let you know, if I wanted to do a failover myself at this point, like actually manually failover, what would I do? I can't because nobody's synchronized at this point. So anytime you want to go see, can I be synchronized? Just try the failover wizard. It'll tell you, no, you can't do that in any of these kind of scenarios. So let's go look at always on health and see what it actually looks like. Oh, by the way, I tried to fix the problem by doing a 0. What happened? Do you know why this one doesn't run? I can't allocate memory to connect back into SQL Server to even run a 0. I'll show you how I get out of it in a second. So I'm like, okay, great. So what am I going to do now? I need to go figure out why this is actually failing over. So, and obviously the error log gets crazy here and kind of trying to show me there are problems. In fact, if I type the error log out, you can just see this madness is happening here. We don't have enough memory even to print an error log message. So because we've squeezed memory so hard inside the engine for memory that needs, this is a good example of the minimum memory needed just to run something on AG. Certainly it's more than 512 meg in this case. So going into the always on health session, I can see some interesting information here about what's happening. I can tell if I start scrolling down some of the different messages I get from this error situation. So I can see, for example, if I look up here, I can see at this particular time, notice here, insufficient memory. So even the threads trying to send messages back and forth can't allocate memory to do anything. And if I look further at my health session, I'm going to get information to indicate really what's happening here. So I'm going to scroll down here. Yeah, failed to create a log block message. This is kind of crazy. And then if I look at things like error reported, I'll get some more information here about what's happening. Let me scroll down and look at that. Okay, let me jump over here. So I was looking at that. So Always on Health can give me some great information. I think that's wonderful. But I think I was telling you guys the ability to go look at this diag from SQL resource. Let's say that I couldn't even get these X event files for some reason because the engine for it is not available. Inside your log file is these SQL diag files. This is not an X event session in the engine. This is us knowing how to write an X event file from our resource DLL. So I can merge these together and get deep diagnostics of what might have happened. So if you look over here, I get info messages about what is the state and health of the system. And if I keep scrolling a little bit further on this, I'm going to add some columns here. Let's add what is the information message from these things? And there's something called a state that I'm going to add as well. So if I add a state, I'll look down here, and I'm going to scroll down here, and things look like what's called clean. This is before I actually did the craziness of doing that memory message. So scroll down here. If I go back up here, notice I'm dumping out ODBC timeout information. Remember, this is a client of the server. So this resource DLL is able to dump out diagnostics as a client to do that connection with SQL and see there's a timeout going on. And can you see here it says warning? This is because right before this happened, that stored procedure ran and knew we were starved of memory. It came back and said, oh, you're kind of running low on memory here. It's one of those errors I talked about, but it's not an error state yet. But error got dumped out so quickly that it couldn't come back and connect and run again. So there could be a scenario, by the way, where you're low on memory, but not totally low yet, where that actual diagnostic could come back and give an error and cause a failover to occur before you really ran out of memory. So it is possible to use that flexible failover policy in some scenarios to be very granular about when to failover and when not to failover. So I get more detailed information as well from this. This is just a way to show you how you can offline look at a failover situation. If you've never looked at a cluster log before, that is also very valuable because this is what the Windows clustering system thinks happening in your system. Now, since we're a resource DLL, besides X event, we will print out information in the cluster log as well as part of the participation of what we talked about, like the is alive and the health check timeout and the lease timeout. So if you're trying to wonder, how do I go see some of the things that the cluster manager thinks is happening, you can use this cluster log. And notice we actually put the word SQL Server Availability Group in the cluster log with the word RES. Those are sections you can go look at to see what was the resource DLL telling the cluster manager at the time of the problem. Notice we had this warning state like we saw in the diag file, and eventually you can see we can't connect to the server, and we eventually schedule an actual failover happening. And we report that's an actual is alive timeout or is alive problem happening because we can't do that. Because back when I showed you that diagram, what's happening here is before the lease timeout's kicking in, right? And here's the thing that's interesting. You know that lease worker? It doesn't have any memory it needs to allocate. So the lease worker thinks the lease timeout is not being invalidated here. The looks alive is fine. But the query can't be run because they can't get memory. So this is where the health check timeout would come in. It's a good example of us having two layers of protection to decide, is SQL Server unhealthy, except for just a service going down or hardware issue coming on. It's a better detection of the health of the SQL instance. And then if I went back to the error log, I can see, okay, what caused all this madness at the beginning? Well, some idiot named Bob Ward went in and changed memory from 0 to 512. That led to this craziness all stopping here. Obviously, you would never go do that in a production system. Any questions about how I showed you how to use some of the techniques? Always on health file, the diag health file, the X event file, and the cluster log, all to see a combination of what actually happened behind the scenes. Does anybody know how I got out of this? Because I couldn't change it to 0. Anybody want to take a guess? What's that? Dedicated admin cache. Actually, that wouldn't work either because it still thinks I've got memory configured at 512. Anybody want to take a shot at that? Anybody done that? Yeah, go ahead. Restart single user mode, that's true. What is required to do that, though, to make this work in your single user mode? Because otherwise you're going to get locked out. Well, it's already shut down. Yeah. Yeah, so you start with single user mode, and there's another option to say only allow SQL command to get in. So then I get in with SQL command, I set it back to 0 and restart it. That's how I got out of it. So in case you ever run into that in your production system, there's a tip. You need to use that other option to make sure the app name is the only one allowed in, or you're going to get locked out yourself. So not dedicated admin connection, but just single user mode. Put in the -m option, which is your app name. Use SQL command for SP configure, and then it'll work from there. You can't use SSMS, by the way. It tries to open too many connections to actually go do that. Okay, let's talk about extending availability groups. And I want to make sure I cover and show you this link feature for managed instances at the end. So you may not have certain opinions about these, but you have different allow connection settings for your secondaries. Did you know that you can actually set up your secondaries to not even allow anybody to use them? So like if you wanted to make sure for like this high availability license scenario, I don't want anybody to try to even connect into those things and use them. You can actually have a connection setting to do that. And you have connection intent, as you may know, with your programs and your drivers to say, I want to make sure it's a read-only connection coming in. Read queries on secondary replicas use snapshots by default, if you did not know that. So we use snapshot isolation for you behind the scenes. And though, if you use accelerated database recovery, we will use the versions in the database, not in TempDB, to create a version store for those versions. You can do backups on secondaries. If you didn't know, DTC and cross database are supported past 2017. And here is one of the hidden gems of this entire system. Did you know, for a normal AG, that if we detect a page is damaged or corrupted on a primary, if you're running Enterprise Edition, that we can go to the secondary, find a clean page, bring it back to the primary, and do an online auto page repair for you automatically. And we do that in the cloud for you behind the scenes, in some cases, if we detect that. Definitely use multi-subnet failover in your connection string, even if you don't have a multi-subnet. There is a better, faster way to make sure we route you faster to do a failover for your actual primary application if you use that connection string. We have a new feature in SQL 2022, query store on secondary replicas. Yes, I realize it's still under a trace flag. I'm sorry about that. But it still exists, and it's still possible for you to go now do query store and capture queries on secondary replicas. Yeah. I'm sorry? Not yet, because the trace flag is still needed right now. So we're still working on trying to get that in the CU update. Okay, so contained AGs, I want to just briefly mention this. Instead of going to a deep architecture, it is something in 2022 we shipped. And the way this technology works is this. We have a listener, and if you connect to the listener, you are redirected to a different set of databases which represent your system databases. So effectively, and SQL Agent's been enhanced to do this. So effectively now, when you do a failover to a secondary, if you've used the listener to add an agent job, it shows up automatically on the secondary. Why is that? Because these are actual databases to the AG system, so the log changes are shipped to the other secondary. If you connect directly to the instance, it doesn't work this way. You must connect to a listener or direct database context to see this actually happen. SQL Agent on a secondary, by the way, knows not to run jobs in these special MSDB databases and only run it on the actual MSDB on the instance. But of course, when you fail over and you use a listener, it knows now, oh, I'm on primary now. So I can run agent jobs both in the MSDB and the contained AG and on the direct instance itself. So we talked a little bit about the cloud. There is a new easy way to deploy availability groups in the portal. And I can encourage you to actually look at that. And remember, you can actually extend your license for disaster recovery using an async replica in Azure VM. We talked about the fact that business critical auto deploys and maintains an AG, but we have a different system for failover detection, so you only need one secondary to be hardened to actually do that. We have this new thing called managed instance link. So what I'd like to do is kind of skip forward and show you a demonstration of what that looks like. So this is brand new, and I realized this. We were here a year ago talking about this. You remember me being here a year ago and, hey, we got this managed instant link thing, right? And it's an offline system. This is your first look at a failover between a SQL 2022 instance, a bidirectional failover between these systems. Behind the scene, we're building a distributed availability group for you, even if you don't have an AG. So this is a new experience in the latest version of SSMS to go and create a new link. By doing a new link, I'm effectively setting up a DAG between my primary in SQL 2022 and managed instance. It does not require a business critical service tier. It can be general purpose. Because guess what? Behind the scenes, we already have the AG technology enabled for you to make this happen. So I'm going through the process of just taking a SQL 2022 and setting it up and connecting it to managed instance. When I'm doing this, I'm obviously seeding the database and I'm replicating the database. We do not yet have the ability for you to manually seed. So we're going to use direct seeding to make these databases work in the beginning. I realize for very large databases, that could take some time. This is the initial public preview for it. So I'm connecting to my MI on managed instance. I'm showing you here the MI I'm going to actually go to because I need to deploy to the MI first. So let me go over and get connected to it, connect to my MI itself, and I go through the process of picking my primary and secondary, the primary being SQL 2022, the secondary being MI, and it's going to go through the process just like if you built a DAG by yourself. And when this is done, I should be able to go over to Management Studio, and I should be able to see the fact that these AGs show up. I time-lapse it a little bit, but you can see now what's pretty cool in SSMS, you can see the actual AG and distributed AG in the system. And you can even scroll down into Managed Instance itself and see that. Let me flip forward and show you what it looks like from a DMV perspective. Even the DMV show this information. So if I go over here, I can run DMV queries and see the fact that I've got an actual primary and a distributed AG. Notice here it shows me the primary is the one in SQL Server, and the AG is the one that's going over here in Managed Instance. Now, one of the things that's really cool about this technology, if you didn't notice or not, for Managed Instance, we have something new called a hybrid failover right. You have the ability in this scenario to mark the MI as a DR site, kind of like the passive scenario for EMs, and you do not pay for the SQL license while you're doing that. So if I say in my managed instance, this is an actual DR site, while I'm not using it, I'm not failed over yet, it's a free SQL license. But I'm going to fail over now. So I'm ready to go do a failover, and now I realize this looks like a manual process, and it is, because this is a async distributed availability group. This is no automatic failover yet allowed for this technology. But I'm going to fail over now, and when I do it, I expect my managed instance to be my primary. So I'm going to come over here and refresh and see that, yeah, my database is there on my SQL Server, but how do I know that this is the primary, this is the secondary? So the GUI kind of shows you that, but if you go back and look at the actual DMVs, you can see now it's flipped. Kind of see right there, even in the GUI it says secondary, and right here, if you look here, this is the primary that's not marked secondary. But I like to go over and look at these actual queries on the catalog and DMV views to show me, hey, I want to make sure which one is the primary replica. And if you run it again, you're also going to look at things like updatability. You can see now that for SQL 2020, it's read-only. And for MI, it's read-write. So you're like, Bob, that's pretty cool. That's interesting. But I want to go backwards. Now you can. So I've got this system where the MI is the primary and SQL 2022 is the secondary. Let's say SQL 2022 went offline. If you bring it back online, we'll synchronize it back just like we do for AGs today. And then when it's synchronized, you can go through the process of actually doing your failover. Now, you need to make sure it's synchronized. You can decide for yourself if it's a forced failback or a planned failback. Because think in your mind of the manual, the cluster type equals none scenario. That's what we've built. Cluster type equals none, where you do a planned failover or you do an actual forced failover. In this case, I know I'm synchronized back, so I'm going to say planned failover, but I'm going back to 2022 now. I was on MI. Let me go ahead and connect to the MI system itself and go through the process of saying, hey, I'd like to switch back. So I'll say, I'm going to keep the link around because I want to go back and forth and just switch back and forth. Say finish here. Now, as you're seeing this, all of this is scriptable. All of this is scriptable with T-SQL and PowerShell. So if you'd like to do this in a more automated fashion, you can absolutely do this. When I refresh here, now my MI is back my secondary and SQL is my primary. So finally, after a year of promising you that this technology would be available, it's been in private preview for a bit, now in public preview for you to go try out yourself. Questions about this one, about how we've implemented this and how you can use it. Works for standard edition too, by the way, yeah. What's the question? The question is, where's the listener? There is no listener yet. There's no abstraction here. There's no auto failover. This is like a DAG you use yourself where you don't have a listener. That's something we need to add into the system. That's what they want to do. Have an abstraction point so your app doesn't know and can go back and forth. Crazy 45 minutes. Whoops, go ahead. Yeah. 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 Well, no, actually you can't. So if SQL 2022 is down, there's no way to connect to establish it back. What you probably have to do is remove the link on the managed instance side and go back and start again, like a reseeding operation. Okay? Yeah. Right, but it's been down, right? You have to probably recreate the link in that case, but come talk to me and I'll see, did the team solve that for you, or? Oh, is that okay? All right. Well, if that's what they said, that's the truth. One other question and then we'll end, and I can stay here for questions afterwards. Yeah. I'll have to take that offline. I mean, off the top of my head, I don't remember. There are some of those kind of things, but I didn't cover that today, but I'll have to talk to you offline about that. Hey, thank you for being such a great audience. I'll stay around here, take your questions afterwards. Thank you.
Yeah. Good? Okay, thanks. Good afternoon, folks. First things first, thank you for coming. I know it is Friday afternoon, probably one of the last sessions for PASS. So I know if you guys are here, it's because you guys want to hear what I have to talk about. So thank you for the opportunity. My name is Hugo Queiroz. I'm a senior program manager for the Azure data team at Microsoft. I am the PM responsible for data virtualization and object storage integration for SQL Server. I've been working with Microsoft for roughly 10 years now. Most of that time, I was a field engineer, so my daily job was always going from customer to try to help them get the most value out of SQL. A couple of years ago, I was invited to join the product team to help SQL Server 2022. On a personal side, I'm a full-time computer nerd. I love hardware, I love CPU, GPU, measuring stuff, overclocking, underclocking, all of those things I love. I love RPGs, tabletop games, all of those things. And for the past 5 years now, I've been trying to learn how to play the guitar. Yeah, it's been 5 years, and I still can't play my favorite song, which is Stairway to Heavens. I still can't play that. I have 3 guitars at home, and I can't play them. Which comes to a kind of a problem because now I'm considering acquiring another guitar, but I don't know how to tell my wife. So if you guys have any questions about any kind of advice about that, I will take it. That said, I think that you guys are not here to discuss my lack of guitar skills or talk about music. I mean, we can do that, but I don't think that's the most valued opportunity for PASS. So let's go through the agenda today. So we're going to talk about the principles and the benefits of data virtualization. We're going to talk about the journey that SQL has in this space. We're going to talk about the architecture of SQL Server 2022, a little bit about object storage, Parquet, Delta, the difference between Polybase v2 and v3, how do I start doing that, the use cases that we are looking for, and like a tool belt, some kind of script, some kind of what you need on the field to troubleshoot to get the best out of this, and what's next. So hopefully we can go through that in roughly 1 hour, but we'll see how that goes. So before we start into the technical stuff, let's just kind of set the ground and the foundation level about the principles of data virtualization. So data virtualization, it is actually a broader concept that the market uses. The technology that we use in SQL to do that, it is called Polybase. So you're gonna hear me talking about data virtualization and Polybase, but it is for this presentation the same thing. we have three major principles that we rely on data virtualization. The number one is data abstraction. And by that, it means connecting with external data. It is not a trivial thing at all. You have no control over the external data. So you have a lot of challenges that you need to overcome. Credentials, the type of data, the schema, collation, all of those things. So the idea behind data abstraction is we need to make sure, or at least make a good job trying to hide or simplify that from the user. Otherwise, it's plain unusable. The number two is zero replication. Data virtualization, it is not an ETL tool. We are not in the business of moving data around. By the contrary, we are in the business of not moving data around. We want to leave the data as is and access the data where it is. And because of that, it allows us to always query the most recent data. We are not doing any kind of buffer. We are not trying to collect data from the past. We always want the most active data. That's the major three principles of data virtualization. Even though the name data virtualization, it is again kind of common in, you're gonna see the market calling that data virtualization, sometimes data mesh. I've heard about data visualization as well. It is all the same thing, right? So what are the major benefits? So we know the principles of data virtualization, but what are the major benefits that we see? Number one, I've kind of told, is no data movement, right? Storage is expensive, moving data is expensive. We don't want to waste money on that. Number two is we try to provide a way in SQL Server that you can use SQL Server as a data hub. And by data hub, we mean SQL Server will handle every single endpoint, every single connection, every single external file format. All you need to do is manage SQL, that you guys know pretty well how to do. So the idea is every single application will connect to SQL, and SQL will handle the administration for all external data that you have. Number three is, it is SQL. So you don't need to learn anything else other than what you already know. It is T-SQL at the end of the day. So you can leverage that for your environment. Number four is security, right? So you have SQL, you have the ability to control the level of security each one of the users will have to that external file format, to the external data. So you can leverage SQL power to control and make sure only the right people can access the data that you want them to access. And the final benefit is price. That's Polybase and data virtualization is available in every single edition of SQL Server 2022. You don't have to pay extra for that. So those are the 5 major benefits. Before we can delve into the technical details, let's talk a little bit about the journey here. Kind of quick show of hands. How many of you have worked with linked server before? Pretty much everybody, cool. How many of you know when linked server was actually shipped, the first edition linked server show up in SQL? Any guesses? Almost there. 7. So if we take a look at linked server, we can say that linked server is the first kind of feature in this space that we ever released. It dates back from SQL 7. I have no idea when SQL Server was released. That I can answer. Yeah, I don't know. I would say 97, but that's just a guess. I don't know. So, but let's take a look on the most recent releases of SQL Server. So in SQL Server 16, we actually created a feature called Polybase. We shipped that with Hadoop. And through Hadoop, we were able to access blob storage and do generic ODBC. So we were able to connect with other databases. In SQL Server 17, we enhanced open row set, we improved that. We added support for CSV for Azure blob storage, and we introduced the concept of database copy credential for security purposes. In SQL Server 19, we increased our number of supported endpoints. We increased SQL Server, Oracle, MongoDB, Cosmos DB, Teradata, Linux, and it was the first edition of Polybase with Linux support. That said, we don't support Linux for DBC, but for everything else, we support on Linux. And in SQL Server 2022, we are introducing a new architecture that, for all intent and purposes, I'm calling that V3, like version 3. We are introducing object storage, we're introducing CSV, we're introducing Parquet, Delta, and CETAS. By the way, CETAS stands for Create External Table as Select. I'm going to call CETAS for the rest of the presentation, but whenever I do that, keep in mind that it's Create External Table as Select. It's a pretty long name to keep repeating that throughout the presentation. Have anyone here tried SQL Server 2022 right now? Cool. A quick show of hands. Have anyone here know about object storage? Have worked with object storage before? Great. So I'm no storage specialist, but I can go through quickly what are the main advantages of object storage and where you should use it, and where you shouldn't use object storage. I think that's a good idea. And again, I'm not a storage specialist, but the major difference between object storage is that the way I see it, object storage, it is a new way of storing data. You have the traditional file system, you have the object storage. The major difference is that object storage, by the name itself, object, it treats the data as it is a single object. So every single metadata that you need to access that data, it is stored in the object itself. So that allows object storage to have more like a flat out distribution. You can consider like object storage, it is like a heap table. It is completely flat, the file distribution. The traditional file system uses like a B3 approach. You have folder, subfolder, parent folder, all sorts of things. Object storage doesn't do that. It is a heap. And because every single metadata is stored within the file itself, you have some abilities that you don't usually have with the traditional file system, which is you can create a custom attribute. You can create a tag on your file. You can create a column. You can edit a column on object storage. When you do that on the traditional file system, you end up with file name, file type, file format, file size, date of modification, date of creation. Those things are pre-established. On object storage, you can create those things. So because of that, because it has no dependency of one object to the other and the ability that you have to change those things, it is usually cheaper and easier to maintain an object storage compared to a traditional file system. That said, it is not a replacement for the traditional file system. Object storage really shines when you're dealing with big data. So when you're dealing with analytics, images, Parquet, Delta, all sorts of things, that's usually the default solution you have. Pretty much 90% of the market will do some kind of data lake architecture over object storage. But for OLTP, small transactions, that's not a good place to be. You stick with the traditional file system. So the reason why we are bringing that into SQL Server 2022 is pretty much because of what I just said. Pretty much every single data lake that you have available runs on some sort of object storage, right? Object storage, it is the traditional way was invented, I think, 20 years ago. But I think 15 years ago, AWS S3 kind of created this standard, the API, the framework that every single object source must have to be compatible, which is the S3 compliant API support. So in SQL Server 2022, we support every single object storage that uses this S3 API. It is not AWS only, GCP, it is on-prem as well. You have MiniIO, you have Pure Storage here, you have Dell. We have companies that are creating a hybrid storage which do traditional file system and object storage in the same hardware. And the cool thing about object storage is that it is either hardware or software based. You can spin up your object storage on a container image and run on top of that. So you don't need special hardware for those things. If you have an old storage, you can spin up, virtualize that, and run on software base. You don't need to acquire new hardware for that. The way object storage uses to connect with other endpoints, it is through REST API. So that's why we have a new architecture in Polybase in SQL Server 2022 based on REST API, because it leverages that to access data. So far, folks, any questions about this? Okay. So jumping into the architecture of SQL Server 2022. So we have, let me get the laser pointer. We have the three major commands that SQL have in Polybase, which are open row set, create external table, and create external table as select CETAS on top of SQL. That's a native available in SQL Server 2022. And then you have two versions of Polybase running at the same time in SQL Server. You have Polybase version 2, and you have Polybase version 3, which is the new version that we released. Polybase version 2, it is the same that we are working since SQL Server 19, which is what you use to access other databases. If you want to access another SQL Server, if you want to access Teradata, Oracle, Mongo, that's V2 that you want to use. If you want to access storage, S3, Azure Blob Storage, and if you want to leverage Parquet, Delta, CSV, that's V3. SQL is smart enough to know the difference between both, so you don't need to worry about that. You do your due diligence, you install Polybase, and SQL will know when it's going to use V2 and V3. I'm just kind of showing the architecture so you guys can see how we are and probably guess where we are going in the future. But that's something I can say. I can just hint. So comparing both, we can see that poly-based v2, it is service-based. You need poly-based services for that to run, while poly-based v3, it is REST API-based. Poly-based v2, the main target are databases, while poly-based v3, the main target are data files. Right now we are working with Parquet, Delta, and CSV. In the future, God knows what we are going to support. Both of them support Azure Blob Storage, but only poly-based v3 also supports S3 storage and Azure Data Lake Gen 2. Poly-based v2 and poly-based v3 requires poly-based installation, but only poly-based v2 requires poly-based service to be running. Poly-based v3 doesn't require the service to be running, just needs to install the poly-based. So let me jump in. How do I start that? This sounds like a kind of a complication, right? So how do I get started installing poly-based and running poly-based? So the first thing you need to do is, when you install SQL Server, you need to install poly-based. It is not installed by default. So in the wizard that you have in SQL Server, you have the poly-based service, query service for external data. You have to check that, and that will install poly-based. And that will install two poly-based services. You're going to install poly-based engine, and you're going to install poly-based data movement. Those two services are installed when you check that box. That's what that box actually do. So poly-based engine, pretty much it is like a query processor. It will do the parsing of the query. It will generate a query plane, while poly-based data movement, it does the communication between endpoints. That's poly-based v2. Then once you do that, you made the installation of SQL Server 2022. You install poly-based query service for external data. You have those two services. Then you need to access your instance. When you access your instance, you have a few SP configure to set up. Have anyone here have worked with poly-based before? Is that any one of those SP configures is common for any of you? Oh, that's great then. Then in this case, we can start fresh. So we actually have two major SP configure that we need to enable to use poly-based for SQL Server 2022. The first one is poly-based enable, and the second one is allow poly-based export. The only reason why we need that formal consent that you are enabling the SP configure is the fact that you are dealing with external data. So we are assuming that by doing that on SP configure level, your admin knows that. We need to make sure that. We have two different options because allow poly-based export for CETAS, you are exporting data out. So we need an extra layer of security to make sure only the right people know what they're doing, right? So that's why we leave that on SP configure. A lot of the people ask why we don't do those things automatically, because we rather do that on SP configure to make sure everybody knows what you're doing, right? So you did the installation, you added the feature, you set up the SP configure. Let's work with the poly-based objects. Let's say you access your database and you want to get that working. So one way you can look at this, like being SQL agnostic without knowing a lot about SQL, is you need to know three things to work with poly-based. You need to know the type of data you want to work with, you need to know the location of that data, and you need to know the operation you plan to do with that data. So if you take one step down, as for data type, we support database objects. That means another database or a file, a CSV, a TXT, a Parquet, or a Delta. As for location, you have a database server or a storage. And for operation, you have read or you have write operation. So you have to define that whenever you're working with poly-based. And expanding that to the whole capability of poly-based, that's how we usually see the full length of the poly-based capabilities, right? All the connections, all the file supports. And if I'm color coding this, just to make a reference for the next slide for SQL, those are how, the color is how it matches inside SQL. So all the red boxes, it means you're working with a file format. All the blue boxes, it means you're working with a data source. That will make a lot more sense in the next slide, I promise. So this is one slide that I actually stole from Bob. He does an amazing job explaining this way better than me. So you have the poly-based engine, you have the poly-based features, so you have the poly-based instance configuration, which is SP configure, and you have your system database. You create your database and you have your system tables. then you need to create a database credential. The database credential is used for accessing your data source. So if you are accessing another location, chances are you're going to need a user and a password, a user, a secret, right? So we don't expose that to the user, we need to encrypt that. That's why we use the master key. So we use the master key to encrypt the credential that you're going to use to access your external file. After you do that, then you create your external data source. The external data source is what you're going to use to locate that file. It is a location pointer. It is a URL or an IP address or something like that. It is just a pointer to the file that you want to access. And then you have underneath here some of the options that we have. We have Azure Blob Storage, Azure Data Lake Gen 2, S3 compatible storage. On top of that, if you want to export data out, you can create this external file format, which is, I'm going to control how I'm going to read that file. I'm going to control how I'm going to export the file. This is useful, for example, let's say you have a file that you don't know if it has a header, or you don't know the string separator, or you don't know the page breaker. Those things stays in the file format. Those things you configure in the file format, and you create a standard for that. That's particularly useful if you're exporting data out, because when you export data out, you can also control the level of compression you have. So depending on the type of file you have different levels of compression. And then you have the real operation, which is the open row set, the external table, or the CETAS. Any questions so far? I know this is kind of convoluted. It will make more sense when I go into the demo. Go ahead. Yes. You would be using Polybase v2 for that, which is still in some ways better than linked server, but all comes down to the use case. So for your case, you have both. Both would work, either linked server and Polybase. The major advantage for Polybase is that you can control on a table level who has access to that. Linked server, you have access to every single table or none, right? Polybase, you have the control of which table you want to access on the Oracle side. So that's one major benefit that we have. Oh, and I forgot to mention about row support, but that's a given. So we have actually 3 major use cases for Polybase going on with our customers right now. The number one is being a data hub, which is you use SQL Server to connect with every single endpoint that you have, an Oracle database, a Parquet, a Delta Lake, a Data Lake, a DB2, whatever it is that you have, and everybody connects to SQL. And SQL will do that connectivity, will kind of make it sure it is not complicated for the end user. SQL will handle the credentials, SQL will handle the data sources. Then you can do some analytics. SQL is not your go-to solution for analytics, but we are seeing more and more that people will use their OLTP database to handle analytics because that's where the data is. Instead of moving the data to another place to do analytics, why not try to do with SQL perhaps in a different time? Perhaps using resource governor to make sure it doesn't conflict with OLTP, and simply because it is cheaper, right? And the number 3 use case we have is offloading cold data. So how many of you here have a database with a bunch of data that is stays there for compliance reasons, for CELA reasons, but technically you don't need that data there? But someone tells, pretty much everyone, but someone tells you you need to have that data accessible in some way, shape, or form in SQL. So you can't offload that normally, but you wish you could. So the idea behind the offloading capability, it is something that we introduced in SQL Server 2022, which is every single code data that you have, that every now and then you need to access, but you won't change the data, it is read-only, then you have a reason to use Polybase to export data out. For all intent and purposes with Polybase and create external table, your application will think that's the data is inside the database. It doesn't know the difference. So you can offload that data out. We actually do have a customer case. It is a financial institution with more than 12 terabytes of data, mostly about compliance issues and contracts with vendors that they needed to stay on SQL. With external table, we managed to keep that less than 1 terabyte. Everything else went away into external table. That's actually a true story. Any questions about this slide, or I can jump into the demo showing those things? Okay, so I'm using wireless, so bear with me here. I have no idea how that will go. Hopefully well enough. Okay, so one thing that I think it is interesting to put in perspective, the demo that I'm running here it is running on top of a very old and normal desktop. It is not even a server. It is an 8-core CPU. It's nothing special. So you're going to see the numbers that I pull in here, taking consideration that I'm running a computer-grade normal desktop level CPU. And that's actually on purpose. So I have the installation done. I'm going to create a database. I'm going to call that PES demo 2. I'm going to enable the SP configure polybase enable because I plan to use polybase. That's the whole idea why we're here. I'm going to create a database. And I'm going to create a master key. I just created this fancy way of creating the master key simply because I don't want to type a complicated password, so I'm doing an auto-generated password. But it is just a master key, nothing too fancy. Once I create that, we can see in the symmetric keys, DMV. Hold on. I do have a recording of this, but I'm hoping to do this live. So we have a database master key created. And what I'm going to do is I need a data set, right? I need some data to show. I don't want to use Adventure Resource because that's what everybody does. So how can I do that? We have this Microsoft Azure public dataset website. So it is a really cool website that we publish. Let me go into here and show you guys. Azure dataset, open datasets. We have a bunch of datasets, all in Parquet files about any kind of data that you want to work with. You have New York, Texas database. You have COVID, Bing COVID information. You have labor information. So if you want to practice analytics, if you want to practice SQL, this is a really good way to start. It is free. And some of these data sets, which is one of them that I'm using, it is live. So it is updated every single day. So the data that I'm going to use for this demo, it is actually based on, let me show, come on internet. Yeah, my VPN is struggling right now. I'm doing Seattle safety data. What the Seattle safety data set means is whenever anyone from Seattle calls 911, it is stored in this database. So 911 can be for any kind of emergency, right? And that's a live data. I swear I'm trying to click, but the latency is not doing a huge favor. So that data set, it is public. And all I need to do is I'm going to create a data source pointing to that location. It is right now stored on Azure Blob Storage under this location if you go into the Microsoft website that I've just shown, you can copy this URL. I don't need to specify any credential or anything fancy because it is a public data set. I'm going to create that. And I'm going to do a normal SQL query on top of that data. I don't know the column name. I don't know the data type. I don't know anything about that data. All I know is that it is a Parquet file. So I'm doing a star Parquet. So I'm doing what we're calling a wildcard search, which is give me everything that you have under that folder. That's pretty much what I'm doing. I'm going to run that query. Of course, it's going to play, latency will play a role here, especially because this data set, it is stored on a public Azure Blob Storage, and it is quite slow. So the latency has pretty much nothing to do with SQL. It's more between SQL and this data set. That said, it felt pretty fast. Even though I'm doing a top 100 here, I don't want to kind of hide this for anyone. I'm doing a top 100. But I can play this with way more data. Let's say how many rows I have available for me in this data set. If I do a count, I have roughly 1.8 million rows in this data set available for me. So let's say I want to learn a little bit more about how that data stays, how is that data organized, how are we accessing that data. I have two major functions that it is available on SQL Server 2022 that was only available on SQL Synapse, and Azure SQL Database, which is file name and file path. With those two functions, I can point to that location and ask SQL, give me whatever metadata that you have from that data. So now I know the full path of the data. I know it is under this folder called city data container. I know the safety folder. I know the release date. I know the kind of the subfolder, and I know the name of the file that I'm trying to access. You can see that Parquet file usually has like a hash name associated to that, and now I have more information about that data, and whenever that data changes, I can check when it changed from this. So right now, I'm doing all of that without knowing the data type, the column, nothing like that. since I want to keep working with open row set, whenever I work with open row set, I need to specify this command book, I need to specify the format, I need to specify data source. Since it's kind of, it can be, you can make a typo, it is a lot of things to declare. I'm just gonna create a view on top of that, so I can work with the data as if it is a normal view. And in this moment on, for example, if you tell your developer or your database engineer, this is a view and he doesn't care about what's going underneath. I'm gonna run the same query, pretty much the same time. The first one was around 4 seconds, this one's about 2 seconds, getting the same data. And I'm accessing actually a view right now. Underneath, I'm doing the open row set, I'm doing the polybase, I'm connecting with the endpoint, I'm accessing the data sets. But for all intents and purposes, from an application perspective, it is just a view. So let's keep working with that. Keep in mind that all the data that I'm doing right now, nothing it is storing on SQL. It is collecting that live. Let's understand a little bit better how that data is distributed, right? So I can see from that data set that we have a bunch of data divided per year and per month, roughly 5,000 to 6,000 rows each month, and we can see that's actually live. It goes from 2003 to 2023. So right now, this month, we have actually 5,01911 calls for Seattle City. Now I want to know, right, I want to kind of do some kind of ingestion, and I need to know a little bit better about the columns, the metadata, the type of data I'm working with. I know I can access that because Parquet file has that information, but let's say I want to eventually bring that into SQL. I want to do some data ingestion. So eventually, I will need to create a table. And if I want to create a table, I will need to define columns, for example. So let me see if I can see any information that can help me out, create a column or create a table with this data set. So if I do this SP describe first result, which is also available in SQL Server 2022, what I get as a result is, you can see here, the name of every single column from the Parquet file. You can see the data type that I'm trying to access, which is a varchar 8000 data type. You can see the length, you can see the precision, and you can even see the collation. Those are available for every single Parquet and Delta file that you have. So you can connect your SQL with your Databricks or whatever it is, or your data lake, and you have Parquet files over there. Now you have the schema discovery available almost automatically. Now you have every information that you need to create a table. Before we continue the demo, any questions so far about this? Okay, it can get complicated really fast. Go ahead. I'm sorry, can you say that again? Yes. That's only, in this case, it is only supported for, I need SQL Server 2022 to do that, but the file, the schema itself, it comes from Parquet. So when you create a Parquet file, the Parquet file handles the schema. So whenever you create a Parquet file, you need to define the schema. What I'm telling SQL is open that Parquet file and tell me the schema that Parquet file was created with. I want to keep the same schema. Exactly. Yes, exactly. That's by default for every Parquet and Delta. I can do that with CSV, but it's for Parquet and Delta. Let's put it this way. It is precise in that manner. So let's do this. I want to work with that data, which is roughly 1.8 million rows, and I'm going to ingest that into SQL. I want to create a table in SQL. I'm going to call the table Seattle 911, and I'm going to ingest every single data that I have from that public data set into SQL. But Hugo, you mentioned that you don't need to do ETL, you don't need to move data. Yeah, but let's say you want to do that. Let's say you want to study that data, let's say the data is coming from your other environment. And for the sake of this demo, I think it is cool just to show the ingestion piece. So blame me for that. So 1.8 million rows coming through the internet took us 3 seconds to do. And again, I'm doing that on a desktop. Sorry, go ahead. No, it is entirely in SQL Server. Yes. So I've just ingested like almost 2 million rows in a desktop through the internet. And again, this blob storage, it is quite slow. I can do this with this machine with 1 billion row. I actually do have a demo of that. If we have time, I can go through that. So now I'm accessing the table locally. Every single data is local. And the reason why I ingested this is because I want to play the second demo, which is kind of the third demo, which is how I offload that data out. So now I created a database with roughly 2 million rows. So let's understand a little bit more how this data is distributed and how I can use Polybase to offload that data. So we know that we have data from 2023 up until 2003. Let's pretend this is your database, has a bunch of data that from several years that you don't use, and you only want to keep data from 2023. That's the only data that makes sense to you. So how do I offload that to another storage and keep only the data that is being updatable in SQL? That's where another SP configure comes to play. We have a SP configure called allow Polybase export, which is I'm going to export data out of SQL. So I need the confirmation. I need to make sure that my DBA knows that I'm doing that. So that's why we need this SP configure enable. I'm going to enable that. And what I'm going to do is I have that data. That data came from, let's do some quick recap. That data came from a blob storage. I've ingested it into my SQL Server. Now I want to say, let's say I want to offload that to an S3 object storage that is running local in my machine. So I got the data from a blob storage public. It is right now inside SQL tables, and I want to offload that into an object storage. So I actually have an object storage emulator running on top of my machine. In this case, it is actually Mini.io software, but it is something anyone can do. It is free, developer purposes. And the interface is this. Let me see if I can access normally. Yes, I have one folder called PAS 2023. Inside this folder, I have two major folders, one called Big Table and the other called Datasets. I want to create another folder here so I can offload the data that I have in my database to this location. So let me go back into SQL, if my VPN allows me to do that. So I need to create a credential, right? This is another location. For the first part of the demo that I ingested the data publicly, I don't need a credential because the data is public. In this case, it is my storage. I need to control who has access to that storage. In this case, I created a user called Contoso admin, password Contoso, nothing too fancy. I'm going to create this database scope credential just to make sure whenever SQL is trying to access this S3 object storage, it's actually using this user and this password. And now, since I created the database scope credential, now I need to create a data source, which is the location of that place, the location of my storage. And the location is actually my IP, because I'm running this locally, but imagine that you have another IP or URL in your company, another address to do those things. Since I'm doing everything in a desktop, it is local. So I'm pointing locally, and I'm telling SQL, use this credential, which is the credential I just created. So this way I can have full control of who has access to what location and what kind of access that person has. Because in this case, Contoso admin has read and write privileges, but I can control that on a storage level. So let's say if you want someone only with read access, you create another credential just with read access. So you have this granular control of who has access to the storage and what the permission they have. So I just created another data source, and you can see here that I did SCP external data sources to see how many data sources that I have. One is the public one that I use to ingest data from, and the other one is the one that I'm going to export data out to. I'm going to export the data as a Parquet. I want to keep Parquet because I know it is compressed. It is like 1/5 of the time, or 1/5 of the size of a normal table. Parquet is really good for compression, so I want to keep that. I want to export the data as Parquet. I want to take the data from my tables and export it as Parquet file. So I'm going to create an external file format from Parquet. And now I'm going to do the CETAS, the create external table, as a select. So when I do a CETAS, what I'm telling SQL is, and by the way, the easiest way I think about reading CETAS command, which can be a little complicated, is go from bottom to top. So what CETAS is doing is get this command over here, which is a select star from this table, get this data and export to this location. On top of that, after you export the data to this location, create an external table called Seattle 2003. So what I'm doing is I'm going to get all the data from 2003 from this table. I'm going to go to this location, which is my S3 storage. I'm going to export the data as a Parquet file to this location over here. Everybody following so far? Great. So if I do that, I exported 11,000 rows. If I go into here and do a refresh, I see this folder over here with the data inside. But SQL also created this external table. So if I go here in my database, let me refresh this. That's database. If I expand table, external table, I can see the external table that I created here. So for all intents and purposes, an application wouldn't know this is an external table. Only an admin would know. So you can now query this normally as if it is a regular table, right? So I've only exported data from 2003. What about all the other years that I have? I only want to keep 2023, so I need to export 20 years of data. So I can create one CETAS for every single year, but I don't have time for that. So what I did was I created a quick cursor, a quick loop that will dynamically create one external table for every single year that I have. A quick loop, nothing fancy, and please don't look at that so much because there's a bunch of errors here. It's not as optimized as it could be. I'm just doing what I would usually do normally. So I'm going to export roughly 1.6 million rows from my database to this location. That took roughly 3 seconds to do. And if I go into here, now I have one folder for every year of data that I've exported. Now I can go ahead into my SQL and delete pretty much every other data. I don't need anything else but this year, right? I mean, my data is already outside, and I have, if I refresh here, I have one external table for each year, right? So far, nothing too fancy. Let me delete all the other data, just make sure we deleted that. Right, so I've just deleted 1.7 million rows. Right, so but I have individual tables for each year, which is kind of the same approach as a partition view. So if you search for partition view, that's kind of the same methodology we are using here. But I want to create a view that unites every single one of those external tables. So I have two ways of doing this. The normal way, the most predictable way, would do just create a view and do a union with all of those external tables, or I can do something a little bit more fancy, which is I want to create a view pointing to the location of the folder, which is Seattle. Let me go into the root of the folder. I know it is stored over here. I know it is stored into Seattle. So I'm going to tell SQL, get every single subfolder from this major folder. And I'm doing this wildcard search. So I get every single Parquet file inside. I don't care how many there are. I don't care. Even if I create another folder in the future, it's going to show up here. So I don't need to specify name. I don't need to name each one of those folders. But just for the sake of comparison, I'm going to do the same thing with a union. I'm going to create a view, doing in union all, everything else. So I have two options now to query that data. I can query the view that I created as an archive, which is the table with the wildcard search, which is the one pointing to the folder, or the table with a union all. Roughly, they should behave almost the same way if you're doing a full scan. And let me, oh, I forgot to, hold on, let me cancel. Let me add the plan so you can compare. The problem is, when you do a union all with every single table, it will do exactly what SQL expects you to do. It will go across every single table. So if you take a look at the execution plan, this might not be the greatest idea of all time. It takes a while to run, hold on. It is roughly 3.5 million rows, right? So let's give it a while. It should take 25, 26 seconds to run. Oh, it's 1 minute to run. So as we waited to finish, any questions so far? It takes 1 minute to run this, okay. You can't export to Delta. You can export as Parquet, but you can read Delta. So the first view just ran. It took roughly 5:52 seconds, so it should take 1.5 minutes to finish everything. Oh, it just did. So the first, again, just to recap, the first execution is pointing to the folder, and the other execution is doing union all with all external tables. So if we compare the plan, that's what you're going to see. The second one, it is, the cost is roughly the same. It doesn't change a whole lot, the cost in this case, because in both cases, we are retrieving every single row. So it has to scan everything. But the thing is, the other one, you have to do one scan per table. So if you are doing some kind of filtering, a where clause, the second one can be really slow. So the reason why I'm showing this is because we see a lot of people doing the union, while we strongly advise everyone just to do the wildcard pointing to the file location. Especially because, let's say, we move into 2024, and now we have to offload 2023, then we have to recreate the view. The other way, no, it's as long as it is inside that folder, we don't care about that. It's always picking up the data. So if we do some kind of search, more detailed search, you can see that the difference between both the cost between both will drastically increase. Hold on, didn't finish the second one. The second one is still running. Yep, it's definitely taking a while. The first one takes 8 seconds, the second one took a while. So now you can see the difference between doing a folder search against every single other column. You can see it is way more costly comparing both. One is 72%, the other is 28%. So if you do a full scan, it doesn't make a whole lot of sense, but once you do a where clause, when you start joining that, when you start to kind of filtering it out, it does make a whole lot of sense to keep that in mind. Again, we can take a look in the folder information, the metadata information from that folder to see how's that data spread out. We know because we saw in the UI, but we know, for example, if we want to access that, we have the information about the folder, we have the full path, and we have the name of the Parquet file. A quick quiz. Let me show here. For every year that I have 8 Parquet files inside. Anyone want to take a guess why 8? That's the guy. Yep, exactly that. So when you do a CETAS command, it will always export the number of cores that you have available in your machine by default. If you want to limit that, you have to control that on a max DOP level. So you need to change the instance configuration or the database configuration to control that. By default, we use everything that you have. So keep that in mind. Otherwise, let's say you have 1 billion rows and you are doing that on a live environment on ETP, that can tank your CPU to 100%. So it is interesting to keep that in mind when you do that. So this also brings to another good point, which is every single CPU will work in parallel. So it is incredibly easy or fast to export it out. So everything good comes with the price, right? Another thing that we can do is, since I'm pointing to the folder location, I can do the wildcard search. I can combine those two things. I can combine the metadata information that I have, that I know where the data is, with the location path. So I can do a where clause using the file path function, telling get me every data from this folder up to this folder, for example. I can play around with those ideas. So what that allows me to do is, now I have 3 dimensions of table filtering. I have the row filtering. I can control which row I want to access with the where clause. I can control what column I want to eliminate with my column in the select. And Parquet, by definition, do both column and row elimination. And now I have the partition elimination, which is I can control which location I want to access. So that kind of gives kind of unlimited number of kind of options that you have, and that's where we can easily work with billions of rows in a small machine, because as long as you play with those 3 variables, you can only access the data that you really want. So that's how we get the most value of the feature. So if we compare that, I can run something like this, or I can run the view, which is the same thing, or the union. The union will, of course, be the lowest one, the slowest one. But before I have, this is pretty much everything that I wanted to show in the demo. I'm ready to go back into the slides, but so far, any questions about this, what we did? Great question. So there's a bunch of reasons why I'm using Parquet. The one that you mentioned is performance. The number 2 is Parquet files. I have all the schema embedded into the Parquet. So whoever is reading that doesn't care about the columns. as well as I didn't care about the column structure when I was accessing that data set in the first place. So I make sure that whenever I'm exporting the data, I'm following the same standard as my database, as my table. I don't need to declare a column for doing those things. So whoever is reading the Parquet file, I don't have to handle schema drifting or making sure the data set is right or the data type is right, or it kind of jumps all of those things and gives me everything that I need in the single file. So I would say for all intents and purposes, I'm a huge advocate for Parquet. I think that's one of the file formats that everybody can use for export data in or to ingest data. I think that makes a lot of sense. And from a storage perspective, it is usually 1/4 of the size of storing that into SQL. So if I have, for example, 100 gigabytes of data, if I export that as Parquet, I have roughly 20 gigs or 25 gigs. So the compression piece is really important as well. That's also an option. Yes, JSON, we don't support JSON for this right now. It is something in the roadmap. So you have that option as well. It has, I mean, as everything else, has pros and cons. So the cons of Parquet is that every single file of Parquet, you can't edit that. It is a solid unit because of the compression piece. So let's say if you want to open that Parquet file to change a row, you can't do those things. That's why you have Delta tables. Delta tables is just like a log file on top of Parquet. Let me go back in the presentation. So to kind of go through the demo, we did those three things, right? We used SQL as a data hub, connecting SQL with another endpoint, a public endpoint. We ingested that data, we did some analysis, and then we offloaded that data. So those are the three major scenarios we see that happening with SQL. So what are the common challenges that we have, that we see on the field? And my good friend Nathan is here in the front. He's our escalation engineer for everything Polybase. So any kind of questions or trouble, you're probably going to meet him. I hope not, but he's here for us. So we have, from a usability standpoint, number one, check your SP configure. None of this will work if you don't have the proper values on SP configure, if you didn't do Polybase enable, if you didn't install the feature, if you didn't do allow Polybase export. That's number one. Number two, you are usually accessing a remote location. So make sure you have the right location and you have the right credential for those things. It is very common for people with an expired credential or the wrong credential for the place. And SQL doesn't always do a great job telling you that you have the wrong credential to access that location. So keep that in mind. Number three is those credentials usually expire. So if you assign a credential to SQL, there might be some network rule that will change the credential every now and then. So you need to change that on SQL as well, otherwise it will expire. It's nothing to do with SQL, it's more about your network security. As for performance, there's a few things that we need to keep in mind. Number one, I'm accessing usually remote locations. The closer the location is to your SQL Server, the faster it's going to be. Latency plays a big role. Number two, this is a recommendation not for SQL, but it is for Parquet itself. Usually, we do a better job when we're handling Parquet files from 100 gigabytes to 10 gigabytes. 100 megabytes to 10 gigabytes. That's kind of the default sweet spot for Parquet files. So let's say you have a Flink application, Spark application, Databricks, Snowflake, whatever, and you're dumping files in Parquet. If you keep to that range, it will be the most optimized range you have for a file. Has nothing to do with SQL, it's just how we work with Parquet. Avoid using, when you're creating a Parquet file, var max. That's a general recommendation, nothing to do with Parquet itself. Just don't do those things. Parquet usually don't do a great job with UTF-16. So keep in mind, whenever you're working with Parquet, if you're not working with the same collation, if you're working for a lot of strings, keep that in mind that you're probably going to use bin2 UTF collations for Parquet. Again, nothing to do with SQL, it's just how Parquet works. So keep in mind collation. Andy from Pure did a presentation, I think yesterday in the environment, in another room, where he showcased the difference between collation. It can be drastic. Take advantage of what I showed you about partition views, partition folders, row elimination, column elimination, all of those things play a big role, and it is the difference between being able to query billions of rows and a handful of ones. So if you plan that right, you create the folder structure, you divide by year or whatever other partition division that you have in mind, leverage that for SQL. That's the advantage of Polybase. And the last recommendation that I would like to give is our friend from Microsoft team, Johan Popovic. He created what he's calling Query Performance Insight. It is a GitHub repository with a bunch of queries in there to help you check all of those recommendations. So you can run his view on top of your database, and he will tell, change this collation, or you're using Varchar Max here, or you're not using UTF-8. So it's like a good tool belt script to have if you're working with Parquet. Yes? I don't know if Microsoft charges for ingress, and I don't know, to be honest. I don't think so, but I think you only pay for the storage, but don't quote me on this one. I really don't know. So. Go ahead, sorry. Mm-hmm. Yes. So you can control, when we do a CETAS, we do a CETAS from a select statement. In the select statement, you can use whatever power that you have in SQL to define, I only want to export those columns, and I want to change those columns to this type, to that type. You can do those things easily. And you can even kind of bend the rules a little bit. You can connect to Oracle, do a CETAS as Parquet into Azure, for example. You can do all of those things. I used to do a demo where we got, our data source was actually Databricks, was a Delta table, and we ingested that, we changed that into Parquet and dumped it into SQL. So you can play around with those things. You can use every power that you have with SQL, T-SQL for those things. And that's a good question. I don't know how Parquet handles XML. I can definitely check that and I can get back to you, but on top of my head, I don't know how Parquet handles XML. So let's say you're not a patient, you didn't pay attention to any one of those things that I talk about performance. Focus on the Query Performance Insight query from Johan. It's really helpful. What about tool belt? What are the tools we need as DBAs to manage, to monitor, to troubleshoot those things? We have a bunch of functions that I've used throughout the demo. We have the SP describe first result set, which is a story procedure. We have a bunch of external tables that's useful for both Polybaze V2 and V3. All the demos that I did was focused on V3, but those GMVs are available on V2, and the QPI library. Right, so that's kind of the tool belt we want every DBA to know about Polybaze. For everything else, bug Nathan. So what's next? Let's say you want to teach about this to someone else, or you want to review your content, you're learning about this. Where should you go next? So we recently published this in Microsoft Academy, this course called Introduction to SQL Server 2022, Data Virtualization. It is not as fancy as the demos that I did, but it gets all the right things done well. So you can take that, it's roughly 1 hour, 1.5 hours with the demos in that. You can learn from that, you can review your concepts, you can, and a lot of the things that I've showed here comes from there as well. So it is good to share. And let's say you don't have a SQL Developer Edition, you don't have an environment to try it out, you want to get this started right away. Our good friends at Pure created this SQL Test Drive web page, which they connect S3, their S3 flash storage to SQL Server, and you can run that for free with Polybaze installed by default. So if you want a virtual lab to try it out, to play with those things, you can use them. And you can tell them I told you to do that because they're going to bug me anyway. So any more questions so far, folks? That's the last slide that I have. It is not yet, but someone told me to do that, so I'm going to do that. Or you can ping me on email. Please feel free to grab my email. I have nothing to NDA here, so I can deliver to anyone. Right. So, folks, that's all that I had to present today. I'll be available here for a few more minutes to get any questions that you guys might still have. But thank you. It's been a pleasure talking to you all. And have a great rest of class.